So I had a couple questions that came in over email. If you're walking in, make sure you get me before you leave, okay, Alyssa? Fall 15, number 22, somebody had asked about. I'll get to your questions here in just a second. Fall 15, number 22. Okay, yeah, fall 15, number 22. If you see the word work, that's not for this exam. That's for an exam coming up, exam number 3, which, by the way, will be an easier exam than exam number 2. Yeah, I know, isn't that exciting? And then somebody had also asked, so no on that exam. Make sure you look at the key. The key is on the exams page. If you go to the exams page, there's a key up at the top that tells which questions are on which exams. And then somebody just asked, in general, about finding forces on planes. So let's just review that because that will be on your free response, and we can work the free response. But just in general, when you have an inclined plane, I'll give you the angle, and I'll give you an object, and I'll always give you the mass. So let's say that the mass is, I don't know, 2 kilograms. Right off the bat, there are always at least 2 forces acting. There's always the weight. Be careful that you draw the weight vertically. The weight is always vertically towards the earth. A mistake that I commonly see students make is that they'll draw the weight in that direction, but that is not right. That is not how you draw the weight. It is always vertically towards the earth. And then the normal force is always in that direction. It's always perpendicular to the surface. A common mistake is that students will draw the normal force in that direction. That is not right either. It's not vertical necessarily. It is vertical on a horizontal surface because that's perpendicular to the surface, but on an inclined plane it is not. And then we will always draw our coordinate system in this way, my forces. And when I do that, this angle is equal to 90 minus the angle of the inclined plane. In this case, that would be 30 degrees. So I have these forces, normal force here, and then my weight, Fw, at an angle for this one of 90 minus 30 or 60 degrees. So those are the forces that will always be at work. And then additionally, we'll have some other forces, like for example, we've seen problems where I have some force, like a rope or a tug or something pushing it up the inclined plane. Or you might see frictional forces. In fact, you will see frictional forces. And frictional forces oppose the direction of motion. So you need to watch out on that. Just read the problem or look at the figure and ask, what is the direction of motion? For example, I might give you some arrow like this. I've done this in the past that says it's accelerating up or down the inclined plane. If that's the case, then in this example, the frictional force would be opposite that direction of acceleration. However, if I have an object that's on an inclined plane that is just static, that is where v is equal to 0, in that case, the frictional force is always going to be up the inclined plane because that frictional force opposes the direction of motion. It's not moving, but the object would tend to move down the inclined plane. To use an Aristotelian word, it wants to move down the inclined plane. That it tends to move down the inclined plane. So the frictional force is holding it in place there. Okay? So that's in general about inclined planes. You'll see the free response, which has, I think, 3 questions attached to it, and then there are a couple of multiple choice questions. But 2D forces also come up in about 2 or 3 other questions, so that in different scenarios. We'll look at those. You have particular questions? Yeah, Clay? Yeah, number 11, fall 23. This one? Okay, let's see. An object is moving to the left across the surface, which experiences a frictional force. So it's moving in this direction. That would be like something like this, where an object is, I push it, and then as it moves, it is slowing down. So there's a frictional force acting upon it. So as it's moving in that direction, to the left, there's a frictional force acting in this direction. It is accelerating, right? It's slowing down. It does have a negative velocity. Did I say it didn't have a negative velocity?
Because on the incline plane, when it moves to the left.
Okay, good. We'll get to that. So it does have a negative velocity because the velocity is to the left. The velocity is in this direction. The object will eventually stop, yes, because it has this force acting on it. And then the object has a negative acceleration. So the velocity is to the left, and this object is slowing. The speed is decreasing, and if it's slowing, that means the acceleration is opposite the velocity. This is a negative velocity, so that means it has a positive acceleration. That was difficult, right? Yeah, watch the words. The words are very important. This object does have a positive acceleration. So 1, 2, and 3, 1, 2, and 4 is the right answer there. All right? Listen, I've told a bunch of students this week, but as you're preparing, the best way to prepare, don't watch the videos. Right? If you just sit there and watch the videos over and over, that's probably not going to help you at all. Like you'll think you understand it as you're watching the videos, but I'm understanding it and you're just watching me. The best way to understand is that you go in and you work exams, okay? And then as you work through exams, you find mistakes that you make. You can go back to the videos and find out the mistakes that you make. That's their use. That's a good purpose for them. Or you can come talk to me too. But as you find mistakes, then you correct those mistakes. And when you make mistakes, when you have those little tears in your understanding, then as you correct them, they'll come back stronger, right? And that you'll understand it better. Okay, what other particular questions? Yeah, Abigail? Number 10 on 21, fall 21? Sure. Okay, a person is in free fall. How does the person perceive their weight? It's an important question because it applies to several situations. Let's imagine our elevator problem. Our elevator problem, we have, I know this isn't your question, but it relates to this. I have a tension that's acting upward and then a weight that's acting downward. Or if you look in other problems, a very similar problem is where I have just an object on the surface of the elevator, and in this case I have a normal force, and then I have a weight. You know, the normal force, this is your perception of your weight. In fact, when you stand on a scale, it doesn't measure your weight, it measures the normal force, right? And in this case, the normal force is equal to the weight, assuming you're not accelerating. But if you were to stand on a scale in an elevator that was accelerating upward, you would feel a normal force that would be bigger than your weight, right? Because we say that the sum of the forces, that's Fn minus Fw, is equal to m times a. And if a is positive, that means that Fn is equal to Fw plus ma. So if I'm accelerating upward, my normal force is bigger than my weight. If I'm accelerating upward, my normal force is bigger than my weight. It's kind of like, we're going to get this in chapter 7, but it's kind of like when you're in that thing at the fireman's fair that spins around, the cyclotron or whatever. Like you feel like you're being pushed up against the side. It feels like you're really heavy. Or if you're on another ride that goes up and down, like it feels like you're heavier than you are. It's because you're accelerating in that direction. It's like you're accelerating upward. So here the normal force is bigger than the weight. So if an object is accelerating downward, then that means that your normal force appears to be less than your weight. Because in that case, my acceleration is not positive, it's negative. So the normal force is equal to Fw minus ma. So, all that to say is that when you're in free fall, you don't feel the same weight. You don't feel that. You don't feel heavier. It doesn't depend on the weight of the person. Instead, you feel lighter than your actual weight. It's like when you go on an elevator and it goes down quickly, right? That it feels like you're sort of lighter. It sort of lifts you up off your feet a little bit. Like you feel like you're lighter than you actually are. Or when you're jumping out of an airplane, right, Clay? Like you felt weightless when you jumped out of an airplane. feel weightless because you're accelerating downward at the same rate as gravity. Does that answer your question? I know that's a lot of words to answer a simple question, but it's an important question because it'll come up at least once or twice on the exam. All right, other particular questions? Yeah, Tyrese? Number 18 on fall 21. Is this fall 21? Yeah. Make sure you can do 17 or something like it. There's variations of it. Okay, good question. So this is a lot like your free response back in, when I did, this fall 21? Yeah, I think I did free response. But your free response will be a lot like this. Here, I want to draw my forces. Right? I have a weight that acts downward. By the way, that weight is 200 newtons. That's 20 kilograms times g. I know that it's accelerating down the inclined plane, so that tells me that my frictional force is right there, up the inclined plane, and my normal force is like that. And then I'm just going to draw an arrow to remind me that my acceleration is 3.25. But it's very important that I recognize that it's negative, because when I draw my coordinate system, this is negative x, and this is up here, this is positive x. So it's accelerating in the negative direction. A is equal to negative 3.25. I want to know the coefficient of kinetic friction. Anytime I'm asking for the coefficient, you need to find two things. You need to find the frictional force and the normal force, because the coefficient is the ratio of those two forces. You're going to be finding this in lab next week. So the coefficient is F over Fn. So I need to find both of those. Let's redraw and resolve our vectors. I have Fn is right here, Fk, and then I have 20 cosine of 60 and 20 sine of 60. Okay? Now, be careful, because often we work problems where we say, well, this is equal to this and this is equal to this. Not true in this case, because it's accelerating. The y components are equal to one another. That will always be true, because on an inclined plane, the object will never accelerate in the y direction. It wouldn't be on the inclined plane if it was accelerating on the y direction. So I can say right off that Fn is equal to 20 sine of 60. That gives me one part of that ratio. And so that's equal to 17 newtons, Fn. So now I need to know Fk. Fk is a little more complicated because it's moving. Sum of the forces in the x direction equals Fk minus 20 cosine 60. That's equal to max. 20, that's m. Ax is negative 3.25. So this is max. And then I can solve that for Fk. That's going to be 10 minus that doesn't make sense.
Is it supposed to be 200 instead of 20?
Oh yeah. Yeah, this should be right here. This right here.
Yeah.
Yeah, I made a mistake because my Fk was coming out negative. All right, so I have 100 minus 20, what's that, 60, 65, or 35 newtons. So I have my mu is, no, that's not right either. Did I do that right? Oh, this was 200 over here. I'm sorry. 200 sine 60. So that should be 170. Y'all see what the mistake I made? So this should be 200 newtons. So this is 170 newtons. I was using the mass instead of the force weight. All right, so that's going to be 35 over 170. I get 0.2. 0.2 is the right answer. I just was going on in my head there when I realized that it was wrong. There were a couple of things. Here, when I was calculating this, I realized that my FK was going to come out negative, but it should never come out negative because the sign of the force is going to be determined by the direction of a vector that I draw here. So I knew that because FK was coming out negative that I had made a mistake somewhere. And then likewise, when I was calculating this value, I realized that mu is going to be bigger than 1. Mu is not bigger than 1. In fact, it'll always be something less than 1. I don't even think I had any options bigger than 1. Yeah, I didn't have any options bigger than 1. That's a tough question, Tyrese. Y'all be practicing those because they will come up several times on the exam. David, did you ever do it?
Yeah. You number 15 on 22.
Okay, you're going to have one like this too. It'll be some object of mass in an elevator that's either descending, ascending, or traveling at a constant velocity. If it's traveling at a constant velocity, it's easy. The tension in the rope is just equal to the weight. Right, so if it was the constant velocity, the tension in the rope would be equal to 10 times 10 or 100 newtons. That's not the case here, though. It's descending. So is the tension going to be more or less than 100 newtons? If it's descending, is the tension going to be more or less than the weight of the object? What do y'all think? More or less? When you're in an elevator that's going down, do you feel lighter or heavier? Lighter. So is it going to be more or less than the weight? Less than the weight. So I can get rid of this one and this one. In fact, I'm pretty sure the answer is E at this point because I don't think that I would go from 100, feeling like I'm 100 newtons to, what is that, like less than 1% of my weight, or about 2% of my weight. So I'm pretty sure it's E, but let's go ahead and work it out. I'm going to draw a picture. I'll draw my forces. There's the tension in the rope. There's the weight. I know that the acceleration is equal to negative 4 meters per second squared. So I say the sum of the forces in the y direction is equal to Ft minus Fw. That's equal to MAY. So that's going to be Ft minus the weight, which is 100, is equal to M, which is 10 times negative 4. So Ft is 100 minus 40, which is equal to 60. So E is the right answer. You'll definitely have one like that. If it's ascending, by the way, let's do that in green. If it was ascending, going up, that would mean that the acceleration would be positive, that would be positive, that would be positive, and the answer wouldn't be 60, it would be 140, which is also an option. That was option D. If it's ascending, then you feel heavier. You'll probably see some qualitative, some conceptual questions about that too. You've seen those on past exams, I'm sure. Other particular questions? Yeah, what?
Are we going to have to find velocity whenever?
Yes. So there will be one question. Okay, yeah. Pretty sure there was one like that. Yeah, either velocity or displacement. But yeah, you will have one like this. Do you want me to work through it right quick? You know, everybody good on this? You find the acceleration first, A equals F over M, and then you either find the velocity or the displacement, V naught T plus 1/2 AT squared, or V equals V naught plus AT. In this case, V naught is equal to 0, T is 6 seconds, and then you have to find the acceleration, which in this case is F over M, that's 15 over 10 or 1.5. Yeah, one question. That's a low-ball question, right? You just need to know the equations, but y'all need to know these equations for projectile motion too. So we've been spending a lot of time on forces. We okay on projectile motion? I know we just had the quiz, but I know some of you didn't do as well as you'd hoped on the quiz. Projectile motion or vectors? Are the free response? Any of those you want me to look at? Particular questions or just topics? Yeah, Michael? fall what? 23, number 7, sure. Okay, you're going to see one like this too. It'll be a little bit different, but you'll definitely see one like this. I find that it's useful to draw a picture first. Look at my operation. I have A, goodness, bless you. A is positive and it's not multiplied, so I'm going to draw a vector A. It's 6 units in the plus y direction. So this is 6 units. And then vector B normally would be 3 units in the negative y direction, but I'm doing 2 things to it. I'm doubling it and I'm negating it. That means I'm going to switch it in the opposite direction. So that minus 2b is going to be this direction and this direction. So this is plus 3 plus 3. Because I'm doubling it, so I draw it twice, and I'm negating it, so I switch the direction of it. So that's going to then give me b, 12 units in the positive y direction. Notice that if you got the direction of those vectors wrong, like if you put these negative, then you would have put a for the right answer, which would not have been right. Or if you left off this 2, you would have put 3 units. Actually, that would have been right exactly. It should, like, if it was a minus a plus, if it was just a plus b, it would be 6 in this direction, 3 in that direction, and then the net vector would be 3. That would be for a plus b. Is that clear what I just said? Or did I just confuse you? If I was doing a plus b, I would have 6 units up, and then I have minus 3, because this is 3 units in the negative y direction. So this is my resultant vector. If it was a plus b for that situation. So you'll see the same question, just the vectors will have different values likely, and it might be a different operation. It could be b minus a, or b minus 2a, or 3a minus b, or something like that. Draw a picture. I find vectors is very useful to draw a picture, especially when they're in one dimension. All right, you're going to see one like number 9. Probably see one like number 8-ish. I don't remember. I'm not positive. Don't quote me on that. I don't remember if that was on the exam. I'm pretty sure there's one where it asks you what quadrant it's in, what's the proper angle. You shouldn't be surprised by these. They're almost on every exam. So the more familiar you are with the exams, it's good to be familiar with the old exams, but also, you know, you have to be careful too because the questions will be different. Yeah.
I don't remember what the question was, but it was something for the quiz. And it was asking for the degrees. Do you know what I'm talking about?
I mean, I think that's what I was just saying. Let's see if we can find one. They're not uncommon, so let's see. Anybody have any help on that? Was it about like such and such component is bigger than the other component, and what is the angle of it? Oh, this might be on exam 1. Let me pull up exam 1. Yeah, as you're practicing, realize that there are some questions on this exam that would have been from past exams 1.
There's 7.
Well, do you know what it looked? Do you have it? Somebody have it? Number 7. Yeah, it says vector A. This is number 7 from the quiz. Oh, y'all had different quizzes. What section are you in? You're in 3M, right? This is number 7 from the 3M quiz. I don't remember what exam that's from. But it says vector A lies in the xy plane. It has a negative x component and a negative y component. So I have an x component that is in this direction and a y component that's in that direction. That means I have to be in the third quadrant between 180 and 270. But the answers that I give you are 300, 120, 190, 330, and 230. So immediately, once I know the signs of the components, I can get rid of some of these. Anything not between 180 and 270, I can get rid of. So I can get rid of those three. But then I'm left with these two. And then I say also that the magnitude of the x component is bigger than the magnitude of the y component. So this component is bigger than the y component. They're not the same size. That means that the resultant of the vector is going to be in this half of that quadrant. All right, because the x component is bigger, it's going to be closer to that x-axis, which means that the angle has to lie somewhere between 180 and 225. That's just 180 plus 45. 180 plus 45. So that gives me the answer then as 190. It can't be 230. Oh, is that it? I'm sorry. Okay. So it's 230. It's the right answer. I'm pretty sure there's one on the test like that. I'm 95% certain. I don't always know because I start out with more questions and then I leave them out. But I remember writing one like that. Okay. What else, y'all? Y'all okay on the free response? Have you been practicing the free response? Yes. No. Don't say that. I appreciate your honesty, but you want to know those well, okay? Because it will boost your morale. Trust me, as you go in and you know how to do those really easily and well. And they're just like the past exams. So you want to focus on those first. And then if you understand those, they will help you on the rest of the exam. Other particular questions, y'all? Vectors, projectile motion, forces. You will have to do this, calculating the sum of the vectors. Yeah, Abigail? Fall 18? Okay. Number 23 on fall 18. Okay. You're not going to see one like this. I'm not going to work through the whole thing. We did one in class, but you are not going to see one like this. But let me just say in short, I know that force weight is one vector. That's equal to 220 newtons. And then there are two other vectors here. Because these two angles are the same, those vectors are also the same. I'll just refer you back to, we did this problem in class, or someone very similar to it. And because both angles are 60 degrees, then both of those force tensions are the same. And these angles are 60 degrees and 60 degrees. And then I can draw my coordinate system and resolve my vectors. I have 220. Here I have 2ft sine of 60. That's the y component of those two vectors times 2 because they're the same. And then here I have ftx, which would just be ft cosine 60. But to find ft, then I set these two equal to one another. But again, as I said, not on the exam. No 2D. I mean, there are 2D force problems, but not that one. Okay? That's how you work it. We did do it in class, or one very similar to it. We've done all these in class, honestly. I don't think there's any problem here. All right? Yeah, Vincent.
The response,
2019 free response, question 2. Okay, yeah, so you will see this. I don't remember if there were 3 or 4 questions, but you were asking for D, right? Now, you really have to work the whole problem because they build on one another. Now, if you get the first part wrong, then that means that all the other parts will be wrong, but no fear. If you get the wrong number for the first part, then I'll count off for that part, but then I'll calculate through to see, did you really make errors on the rest of them, or was it just because of that one mistake you made in the beginning? It helps me, like if I can see your work, that helps me to give you credit where you didn't do something wrong in later parts. This is why I don't do, by the way, multiple choice anymore, because, I mean, then it's either wrong or right, but you can make a mistake in the very beginning. Anyway, all that to say, you have to draw your vectors first. So here's my coordinate system. I'm going to draw my vectors. This is 25 newtons. Here's my weight, which is at an angle of 60 degrees. Was that 20 kilograms? Two? Okay, so it's 20 newtons. Well, that is a terrible figure. And then I have a normal force here, Fn. And then, oh, I need to know my frictional force. So this object's being pulled up the inclined plane. So I need to determine the direction of the frictional force. That frictional force will be down the inclined plane, because I know it's accelerating up the inclined plane. Actually, part B, we'll just skip it. That assumes no friction. So it's going to be similar to part C and part B. So let's work part C and B. But first, I need to resolve my vectors. I'm going to do it right here. Fn, that's already on the x-axis. This is 25 newtons. This is 20 cosine 60, which is 10 newtons, 20 cosine 60. And then here, this one is 20 sine of 60. I'm going to do it over here. So 20 sine of 60 is equal to 17. So this is 17 newtons. And then in addition, I have the frictional force, which is also in this direction, Fk. Yeah, Ben?
What's the cosine on the negative y part of the grid?
Oh, I did that wrong, didn't I? Yeah, that should be 20. I got those switched. So this should be 17 newtons, and this should be 10 newtons. Yeah. Okay? Is that clear? All right. So find the normal force. That's easy for part A. The normal force is equal to 17 newtons. Fn minus 17 equals 0. That's equal to the normal force. And then to find, next I want to find Fk. That's for part C. Fk is equal to mu k times Fn. So that's 0.1 times the normal force, which is 1.7. 0.1 times 17, which is equal to 1.7 newtons. So that's part C. There's part A. I skipped over part B, but it's going to look a lot like D. And then finally, I want to know the acceleration of the block. To find the acceleration, I say the sum of the forces in the x direction equals max. Sum of the forces in the x direction are Fk plus 10 minus 25 equals to the mass, which was 2 times ax. So that's going to be 1.7 plus 10 minus 25 divided by 2 equals ax. And that's 1.7 minus. I get 7 meters per second squared. Negative 7 meters per second squared. So it actually accelerates in the negative direction, but in the negative direction in this case is up the inclined plane. So I'm going to qualify that as up the plane. All right, so that's part D, but it requires you to do the other parts. Oh, what year is that? Yeah, I probably just rounded somewhere along the way a little bit differently.
Watched the video yesterday and said for the cosine thing, for the sum of all the forces, it was like 17 cosine 60 plus 1.7 negative 25 equals 2 times A.
The description of that video, you put that you made a mistake on that one.
Okay. Yeah, I made a mistake. I make mistakes just like y'all sometimes. I know that's shocking to you, but I make mistakes. Is that shocking? Hey, y'all, we're still in the health session. We'll be done in just a second. Any other questions, y'all? Yeah, Tyrese? Okay. Why don't we, I'll answer your question, and I'll leave it on, I'll put it on the video.
I
Yeah.
have a quick question about this. So you
Okay.
said subtract 25 because it's on the negative x side?
Right.
Okay.
Yeah, so be careful. This, even though this points up the inclined plane, it is in the negative x direction.
Okay.
Okay? All right. Let me